this video, we're going to talk about a very important concept for a firm trying to make profits. In particular, we're going to look at the conditions that result in the very best possible outcome for a competitive price-taking firm in its choice of labor and capital. So we're imagining a situation where a small firm that takes the market price of its output as a given, so it can't affect the price of the final output. So the price is exogenous, and we depict that by a bar over it. So their decisions don't affect the price. But we're also assuming a situation where the firm can't affect the cost of hiring labor. W, the wage, is fixed as far as this firm is concerned. Also, the cost of capital, the rental rate, how much they have to pay in order to get investors to loan them or rent them capital, that's also constant. But we're allowing them to choose labor and capital in whatever amount they want, given these exogenous market-determined variables. Now, in order to, do the analysis of the optimal choice of labor and capital, we're going to have to use these concepts of marginal productivity of capital and marginal productivity of labor. Again, MPK, marginal productivity of capital, is the increase in output if a firm were to hire one more unit of capital. So this is how much extra output you would get if you could get one more unit of capital. Marginal productivity of labor, MPL, is the analog for labor. It's how much extra output you get from a change in labor. So I've written this more algebraically in the second version with labor, but these are basically the same thing, but one written out in words, the other one used mathematical symbols. So we're going to use this when we start looking at these optimal choices. So now we've got the profits for the competitive firm written out here. We've got profit equal to the price of the good, which is constant. They can't affect the price by assumption. But if they multiply the price times the quantity of Y that they produce, they're going to get total revenue. So price times quantity here is the revenue. But the output is going to depend on their choice of capital and of labor. So that part they can affect. They can choose capital and labor, implicitly chooses the level of output, and it'll influence how much revenue they get. But they don't look at just revenue, they look at the cost of making that level of output. That's the right-hand side here. We've got the wage rate, fixed, exogenous, bar over it. The wage times the quantity of labor that they hire is how much they have to pay their workforce, minus what they have to pay for the use of capital. The rental rate multiplied times capital. Now, if this was an entrepreneur and they're using their own resources, that's essentially how much they're paying themselves for the use of that resource instead of using it someplace else. If they're having to appeal to outside investors, it's how much they would have to pay investors. You can think of this in a number of different ways. But importantly, that payment to capital is fixed by assumption in this setup. So we've got total revenue, price times quantity, minus the total cost. Now you'll notice that there's no fixed costs here. We're allowing capital and labor to be freely chosen. So all of the costs are variable. All of the costs can be varied depending on the choice of how much capital and labor are chosen to the firm chooses to hire. Now, I'm going to break up the choice of labor and capital into two separate decisions. First, let's look at the choice of capital. Now, what they're going to do is to choose capital such that the extra profit that they could get by varying the amount of capital is zero. They can't get any more output or profit by changing the level of capital. So how does profit change when you do vary the choice of capital? Well, how does revenue change? Well, they can't change the price, but if they change the amount of capital, they change the output. So if they see how output changes when they change capital, that tells you how much extra output you get. Okay, this delta Y over delta K, that's the extra output you get by hiring one more unit of capital. In other words, marginal productivity of capital. If you multiply that times the price of what you sell, that's the extra revenue you get by hiring one more unit of capital. How does hiring one more unit of capital affect your costs? Well, you've got unchanging cost of capital. If you hire one more unit of capital, what you're going to have to pay is R, this unchanging market-based cost of capital. And you're going to choose capital such that the change in profit from this choice of capital is zero. We talked about another video how if you have a function and you get just up to the top of the hill, the change is zero. That's what we're going about here. It's the optimal choice of capital is where this condition holds. We have an analogous situation for the choice of labor. Okay? Here, we want to choose the profits so that the change in profits is zero. We're going to pick just the right amount of labor to get that. That's going to be equal to the price times the change in output when you change the amount of labor minus the wage rate, all equal to zero. Now again, let's go back and look at this. This component is how revenue changes when you change the level of labor used by one unit. This is how much one more unit of labor would cost. So let me rewrite these two conditions. And let's call it A and B. Condition A can be rewritten as the price multiplied times the marginal productivity of capital is equal to R. If you choose capital optimally, the value of hiring one more unit of capital, this is how much extra capital you get, how much extra output you get, multiplied times the price. It's the extra revenue from hiring one unit of capital. R is how much you have to pay. In other words, This is marginal benefit equal marginal cost. The marginal benefit of hiring an extra unit of capital is equal to the extra cost of hiring one more unit of capital. That's the best you can do in choosing capital. B, condition, price times marginal productivity of labor is going to be equal to the wage. It's the analog for the choice of labor. Now, which is the extra revenue, the left-hand side here is the extra revenue you get by hiring a worker. That's how much you have to pay a worker. Again, for the competitive firm. These two conditions are sometimes called the marginal revenue product of either capital or labor. Okay, so sometimes you'll hear that phrase. Sometimes you'll hear the value of the marginal product. Different names, same idea. Both of them have to do with multiplying the price of the good that you sell by how much extra of those goods you get by hiring one more unit of the input. Okay, so here are these profit maximizing conditions. Now I want to relate this to what we have seen before. Okay, I've simply, this is this condition B. This is condition A. Okay, so everything just rewrote it on the other side of the board. Let me look at the ratio of these two. I'm going to look at the wage compared to rent, and I'm going to look at the other side, which is the ratio of the value of marginal products. You'll see that there's a price up above and a price down below. In other words, you can rewrite this as the wage-rental ratio is equal to the marginal productivity of labor over the marginal productivity of capital. Optimal choice, labor and capital, will give you this condition here. Where have we seen that? We've seen it with an isoquant and a isocost line. Recall, if we look at the cost of a firm of doing business, we had, and they chose the labor, they could choose between labor and capital, they've got the wage and the rent. The slope of that budget constraint for the firm, the cost for the firm of making the product, was given by this line. What did we have with an isoquant? We had a situation where the most output you could get for a given cost outlay was where an indifference curve was, an isoquant was tangent to that cost line. This depiction of the optimal level of capital chosen and the optimal level of labor chosen was where the slope of the ISO cost line was equal to the marginal rate of technical substitution, which was equal to the marginal productivity of labor over the marginal productivity of capital. This is the slope of the ISO cost line. This is the slope of the isoquant. In other words, we just did an algebraic version of choosing the optimal amount of labor and capital that a price-taking firm would take. That's where an isoquant is tangent to the isocost line. So these are all related. It's different versions of the same thing. To say that the wage or labor is chosen so that the wage equal to the value of marginal productive labor, and simultaneously that the value of marginal productive capital is equal to the cost of capital. If firms do both of those things, it's simply that picture done algebraically. So all of these things fit together, and when you see one, you should think about the other, and vice versa. But it's all related.